The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Do you remember what happens when you rub a balloon on your hair? I'm going to need a tool for this demo. Now I just need a balloon. Static electricity makes for a fun trick, but when it comes to electronic components, electrostatic discharge, or ESD, is no fun at all. In this video, we'll talk about how to avoid building up triboelectric charges, which is a real thing unlike my hair. It's just a fancy word for static electricity. Hello, my name is James and welcome back to Workbench Wednesdays, where we review tools for your electronics workbench. Speaking of the bench, this episode is looking at tools that go directly on the bench, like this ESD mat. It is part of a kit from DuraTool that runs about 150 money units. The reason I picked up this kit is because it includes the mat, a wrist strap, and a tester. In this video, I also show you some additional ESD accessories, all of which I received from the Element 14 community. Now, before I get going too far, I do want to cover a few items. First, ESD stands for Electrostatic Discharge. The shock you get from touching metal is a type of electrostatic discharge event, or ESD event. It occurs because two objects become charged to different voltage potentials. When that difference becomes large enough, the air between them ionizes and briefly conducts. The amount of charge is very small, so the event only lasts a very short period of time. Sometimes you'll see a tiny spark, but ESD events can occur without you feeling or seeing them. While the spark might sting your finger a little bit, if the same potential hits an electronic component, it can be destroyed. So we use tools like an ESD mat and a wrist strap to keep you and the items you're working on connected to earth ground, which means everything stays at the same potential. First, let's take a look at the mat that came with the DuraTool kit. One aspect that affects ESD is the air's relative humidity. So I thought it was interesting that on the box, it recommends unrolling the mat at a certain condition. Now, I don't have an explanation for why, but I think following their direction is just a good idea. This particular mat measures about 60 by 90 centimeters. I would call it a large mat. On my smaller work area, I have a mat that is about 30 by 53 centimeters. Here's how they compare using a banana for size. Wow, that old mat is really dirty. It's a good thing that the DuraTool kit came with this cleaner. Here's the thing, you should not use IPA or rubbing alcohol to clean an ESD mat. It will dry out the rubber and ruin its ESD properties. Only use cleaners made for ESD mats. Coming back to my new one, after unrolling it, you are still not quite yet ready to work with it. You see, depending on how you look at it, an ESD mat is either slightly conductive or highly resistive. This mat is so resistive that my bench multimeter can only kind of measure its resistance. You see, it's in the tens of mega ohm range. Now, that resistance is meant to bleed off energy from a charged up device when it comes in contact with the mat. For the best protection, we need to prevent that charge from building up in the first place. So let's go one step further. To keep the mat components on the mat and you at the same potential, we need to tie the mat to ground. And in this case, I'm talking about earth ground, which I can access by screwing this onto one of my electrical sockets. For North American wiring, that works great. For those in other regions, check out adapters like this one. It plugs into a socket and makes contact with the ground conductor. For example, now I have a place to plug in my ESD mat. And by the way, this is my only UK socket, so I'm using a transformer to demonstrate. Please don't plug an adapter like this into a transformer. Plug it directly into a wall. Now that my mat is connected to the earth, literally, I have an ESD safe workspace. But there's one more element to consider, and that's me, or you. I guess that's two. We can also build up a potential. Now, when I touch the mat, I should become discharged, but it doesn't take much to charge me up again. So that's where an ESD strap comes in. When I put this on and connect it to my mat, I am now held at Earth's potential. By the way, these straps or the cables will have a 1 mega ohm resistor built in. That keeps an instantaneous ESD event, or worse, death event, from occurring. It allows charge to safely dissipate. And just one quick note on the DuraTool strap that came in the kit from Element 14. Like a bad engineer, I put it on and didn't bother to read any instructions. And then after a few minutes, I realized it was really hurting my wrist. That's when I found that there were extra links included in the packaging to adjust the size. So please don't overlook those. At this point, I'm left with a question. How do I know if any of this ESD stuff is even working? As I mentioned earlier, you can't just make a simple measurement with a typical multimeter. So that's where this strap tester comes in handy. It connects to your mat, and then you just touch it. If there is between 750K and 10 mega ohms of resistance between you and ground, the tester beeps and lights up green. By the way, the power supply for this tester includes a grounded cable. The tester gives me confidence that I'm well grounded, at least in terms of voltage. It is the most expensive part of this kit, so for home or hobby use, you could probably pass on it. But if you're in a professional or any kind of shared environment, I do recommend that you have something like it to test your ESD setup each time you sit down to work. By the way, there is a type of strap that goes on your foot, or well, your shoe. There's two things to know about this type. First, the ribbon needs to be in contact with your skin, so I just tuck it into my sock. And second is that these only work on certain floors that are treated for ESD, so wearing this on regular carpet doesn't do any good. They're meant to be used in factories, offices, and labs that have a properly treated floor. Since I'm all charged up to talk about ESD, wait, I'm discharged. Anyway, don't use a regular brush when cleaning boards, connectors, and enclosures. These can build up a charge as the bristles rub against each other. Even if you're wearing a wrist strap while using them, there may not be continuous contact between the bristle and your hand. So there are a variety of conductive brushes that, like the mat, will dissipate static charge instead of build it up. However, for these to be effective, you do need to be grounded, so that means make sure that you wear a wrist strap while you use them. The last bit I want to show you is this conductive foam. When you buy static sensitive parts, they'll come packed in something like this. As you can see, there's no ground connection. The purpose of this foam is to prevent a static charge from building up. You can think of it as like an ESD mat with no earth connection. I recommend storing any ICs and transistors, especially MOSFETs, with the leads in a piece of this foam. A sheet of it is cheap, so pick it up the next time you order some parts. I know some of you are ready to comment that you don't have an ESD mat and you have never had a problem. However, ESD events are not a matter of if, but a matter of when. An important thing to remember is that ESD damage does not always cause a component to fail immediately. Sometimes failure happens long after the damage occurred. An ESD mat and wrist strap are a simple and cheap precaution. In terms of the DuraTool kit, if you don't already have a mat or strap, it's a great value. But keep in mind, everything shown in this video is available standalone as well. Do you have an ESD related story? If so, I want to hear it. Head over to element14.com/workbenchwednesdays and let us know about it. Over there, you'll also find links to the products in this episode, and it's a great place to ask questions about these tools or ESD in general. Speaking of the Element 14 community, I need to give a big thank you to everyone who answered my forum question about measuring the resistance of an ESD mat. If you'd like to try to make that measurement, check out the ideas from the members. A link is in the notes. For now, it is time for me to get back to my ESD protected workbench.